Okay, let's get started on section 12.2. It's going to cover graphs and functions and transformations and how graphs shift and kind of their parent functions and all of that. Okay, so let's go over the basic forms. These are another name for basic forms. It might be called parent. You might see the parent function. That's another name I might refer to it as parent function. That's quite commonly used. So the absolute value function, and any of these functions really, what I want to do is let's make a table of values of input and output values and graph it that way. And then once we get kind of the general gist of what's going on here with these graphs, then we're going to know basically kind of how to set them up, because they're going to get pretty predictable in terms of what you're going to see. Okay, so I went ahead and set up a input-output table. And what we need to do is we need to make some inputs and outputs that can work with the table or with the coordinate plane that we have provided for us. And we have to be able to use this function, f of x equals the absolute value of x. Remember, independent functions, when you guys put an independent function in, you can really put any number in there, given that the domain is like all real numbers. But you could put any number in for the input, and then just see how that turns out for the output. So, and I know some of these will seem really easy, but I'm going to go through them anyway. So the absolute value of 0 is 0. So when you do that, that comes out to 0. I'm going to try 1. So the absolute value of 1. Now the absolute value of a number isn't the opposite of a number. It's just how far it is away from 0. Remember, it's the distance away from 0. So the absolute value of positive 1 is still going to be 1. You put in a 1, you get out a 1. All right, let's try negative 1 as well. Let's say I put in the absolute value of negative 1. How far away is negative 1 from 0? Well, it's also 1 unit away. So you got the same output value whether you put in 1 or negative 1. All right, let's keep going from there. Let's try absolute value of 2. And I'm sure you guys see where this is heading. Absolute value of 2 is 2. And the absolute value of negative 2 is also 2. See where that's going? So if we put a 3 in, or if we put a negative 3 in, we're always going to get 3. So we don't need to kind of keep going through all those iterations of absolute value. Now when we graph this, all right, let's go ahead. What I would highly recommend doing, I would highly recommend when you guys graph functions especially, is not to start connecting the dots until it's all over. I think some people, like they'll make a point here, and then they'll make a point here, and they'll make a connection there. And then they'll maybe you didn't do things in the exact order I did. And maybe they'll put a point there and they'll go, okay, I'm gonna connect that. And then maybe the next point will be down here. And then it looks like just a kind of a tangled mess of numbers. You don't want to do that. So you want to avoid like connecting the dots right away. So just what I would do is I would kind of get some points out on the graph and just see how they kind of relate to one another. So 1, 1's there. There's negative 1, 1. There's 2, positive 2. Here's negative 2, positive 2. 3, 3, negative 3, 3. And you can kind of see it's making this very predictable looking pattern here. And absolute value graphs are going to look like that. So that's going to go that direction. That's going to go that direction. Now where this is heading, let me give you guys a little heads up here as to where this is heading in terms of this lesson for 12.2. But we're going to talk about shifts and transformation. The word transformation just means a change, and in our context, it's going to have to do with a shift. So we're going to talk about how these things change based on some numbers, and we're not there yet. I'll show you what I mean. But like, let's say I want to take these series of points and I want to show you, let's say there's a vertical shift. Well, if there's a vertical shift, they're going to go like that. See, I'm taking this whole graph. I'm able to do this with this program that I'm using, but I can make it shift up 1. It can go up 2 units. It can shift negatively, vertically. It can go down 1. It can go down 2. It can go down 3. Now notice the graph itself is still the same shape. It's not. What's changing are the points and the values on the coordinate plane. So vertical shifts, it's going to go up, and horizontal shifts, it's going to go right or left. So this is going to be a horizontal shift. This is going to be another horizontal shift to in the opposite direction. And sometimes, and we're going to get there too, it'll be a combination of both. It might be a vertical shift of, let's say, up 3, and then perhaps a horizontal shift of left 2. So that's where it shifted. But the general shape of an absolute value graph is still intact. You know, it hasn't changed. It's still that V shape. It didn't get wider. It didn't get more narrow. It's still what it is. Okay, so I'm going to place this back down here. All right, now next going to a quadratic function. This is what we just kind of worked on. We worked on quadratics not too long ago. Okay, so I made my table of values here, or I set up my table. And notice, like, when I set up the table, I didn't just set up the table for like 2 or 3 values. It's not one of those linear equations. It's not going to be a linear graph where it's just, you know, 2 or 3 points will be enough. We want to have several points to graph so that we get a general idea of what the shape of the graph is going to look like, or the shape of the function. So I'm going to always starting out with 0 is always a good place to start. So let's say if I had a function of 0, so 0 squared, what is that going to be? Well, that's going to be 0. It's pretty easy. The function of 1, let's do that. Well, that's going to be 1 squared. Well, 1 squared is going to be 1. Let's say I do the function of negative 1. Now I'm going to put that in parentheses. So negative 1 squared is negative 1 times negative 1, which is also 1. Put in negative 1, you get out a positive 1. So I'm going to follow this kind of general pattern here. Okay, so I think I have a sufficient number of points here to graph and get a good idea of what a quadratic function is going to look like. So 0, 0 is going to go right there. 1, 1 is right there. Negative 1, 1 is right there. 2, 4, negative 2, positive 4. I'm running out of room for the graph that I have. So I have a upward facing parabola there. So that's the parent function right there of a quadratic. You know, so what we're going to do, like I said, just give you kind of foreshadow as to what we're heading to. This is going to shift. You know, we're going to talk about how this moves around. You know, here's the parent function. This is what just f of x equals x squared looks like. That's plain old quadratic function right there. This is what it might look like if it shifted 1 to the right, shifted 1 to the left. All right, shifted, you know, vertically and horizontally. You know, it's shifted down. But notice, the graph isn't widening, the graph it's not getting larger, it's just what it is. Those points are still where they are. It's just that I'm shifting where the coordinates are. So I'll put that back there. All right, moving on to a square root function. Let's go ahead and just make a table of values again. Now, when it comes to a square root function, on the previous ones, I was allowing negatives to go in for the inputs. But for these, I mean, I guess we could put negatives, but we don't want to get imaginary numbers. We want to be able to graph real things. You know, where are they going to be on the coordinate plane? So let's avoid negative numbers if we can. So let's stick with positive numbers like 0. Let's also make them a little easier to use. I'll show you what I mean. So the square root of 0, that's not that difficult. Square root of 0 is 0. I'm going to try square root of 1. Let's try that next. Square root of 1 is 1. Now I could put 2 here, but if I do the square root of 2, I'm not going to get, I'm going to get kind of an irrational number, which, I mean, I guess you can graph that, but let's stick with numbers that are a little easier to graph. So I'm going to think a little ahead here. Let's use 4, because that's a perfect square number. So square root of 4 is 2. And let's use 9 as well. The square root of 9, the f of 9 is going to be the square root of 9, which is 3. Okay, now let's get down to graphing it. So 0, 0 is right here. 1, 1 is right there. 4, 2 is right there. And then 9, 3 is off the graph. And there's what the parent function of a square root function looks like. So let me just kind of make sure this is clear. I think some people, whenever I draw this, some people think, is this going to is that going to level off at some point? And no, it's really forever going to keep increasing. That it's going to keep going up and up and up and up. I mean, if you zoom out, it's going to definitely look like it's kind of getting horizontal, but it's never going to flatten out completely. It's going to keep going up vertically, and it's just going to go up slower, but it's still going to go up. All right, now moving on to the steps for graphing shifts. Let's talk about some of the general rules here. You know, there's rules for vertical shifts, there's rules for horizontal, reflection about the x-axis. So the vertical shifts are going to go like this. What I want to do is I'm going to go ahead and jot down some of the more common graphs. All right, so that's an absolute value function right there. And now what's going to happen is a vertical shift. I know vertical means up, you know, but vertical shift is going to mean up or down. I guess, you know, vertically up if you're going up, you know, positive direction, yeah, that's going to be up. And if it's a vertical shift of a negative value, well, that's going to be going down. So what affects the vertical shift is going to be a plus or a minus. Let's say I put like a +3 right here. If I put a +3 right there, that means that's going to go up 3. I just went ahead and I drew an absolute value graph on there. If this absolute value was, you know, if this function was f of x equals the absolute value of x, that's what it would look like. That's the parent function. Now what I did was I showed it with a vertical shift of +3. So that means it's going to go up 1, 2, 3 units. So if you can recognize the vertical shift, or, you know, either positive or negative, then it's going to be really easy to make a graph here. You know, what we did before was we made a table of values, which is time consuming and can be kind of annoying, especially when you have to make point after point after point. But if you have a general idea of what the shape is, and this is what the shape of it looks like, and you know it goes up 3, then there it is. If it was x minus 3, then it would be 1, 2, 3 down. If it was x minus 1/2, it would be down 1/2 unit. If it was I should say absolute value of x plus 1/2, it'd be right there. If it was 1.5, you know, like right there. But that value right here, this value right here determines the vertical shift of that function. So let's say we have this. Let's say we have a parabola, you know, and a parabolic function, quadratic function looks like this, right? And now let's add a shift to it. Let's say this time it has a shift of -2. So what I'm going to do is I'm going to draw the parent function. Now the parent function of a quadratic is 0, 0, 1, 1, 2, 4, and then it's got some symmetry. Okay, now according to the function that I wrote down, this has a vertical shift of -2. So what we're going to do, let's experiment with this for a second here. Let's bring this down to 1, 2 units right here, and let's lay it there. Okay, now let's see if those points make sense. You know, notice like right here, I have some new coordinates for a point. That is point right there, 1, -1. Okay, does that, you know, in terms of input output, does that work? You know, if I put in 1 and square it, does that give me an output of -1? And it sure does. 1 squared is 1, and 1 minus 2 is -1. So that works perfectly. Right here, I could try another point. Does that point check off? That's 0.22 right there. Let's check that. Let's see if that fits our input-output rule. So if I do, you know, x squared minus 2, and I put in 2, so 2 squared minus 2, well, 2 squared is 4. 4 minus 2 is 2. So yeah, if we put in a 2, we get out a 2. So everything works according to that transformation. So that was a vertical shift of going down 2 units because we had a -2 right there. Okay, so I went ahead and drew I wrote down the function for square root. Now, square root function looks like this, where you have 0, 0, square root of 1 is 1, the square root of 4 is 2. So that's what the parent function looks like right there. Okay, now let's add a shift to this, a vertical shift of, let's say it's +2 this time. Okay, so +2, what that means is it's going to shift up vertically 2 units. So if I show that, there's up 1 unit, and there's another unit right there. All right, so if I want to check this to see if this all kind of works out, let's see if, according to the shifts that I made, does that make sense? So now that point right there, the coordinates of that point are 4, 4. All right, so if I put in those coordinates, if I put in square root of 4 plus 2, does that give me an output of 4? And it sure does. Square root of 4 is 2. 2 plus 2 is 4. So that checks off perfectly. Okay, now just for the heck of it, I want to show you guys. A linear graph right here, a linear function, and just kind of how these shifts work the same way. Now, knowing what you know about graphs, let's say the parent function of a linear function would be like this: y equals x. So y equals x would have this general trajectory. So it's got that general trajectory right there, which is, that's the y equals x graph right there. Now, according to this, the new graph right there, that has a vertical shift of down 3. So it's going to go down 1, 2, 3. And that all kind of makes sense too, because just think about, not even think about the way functions move, but just thinking about how linear graphs work. According to that graph right there, that has a y-intercept of -3, and that is right there, and that's got a slope of 1. The slope equals 1, so it's going up 1 over 1, up 1 over 1, up 1, right 1. It's following that pattern right there, up 1 over 1. So even if it's not even if it's just a basic linear function, y equals mx plus b type stuff, it's still gonna, the shifts still work the same way. Okay, now moving on to horizontal shifts. Now horizontal shifts are a little trickier. And the way you can kind of spot them is it's going to be indicated so look for all indications of a horizontal shift to happen within a grouping symbol of some sort. So when you have in here, let me kind of just go over what I mean here. Let's say we talk about let's start with the absolute value function. Well, this right here, that's the grouping symbol. All right, so what you're going to do is, if something happens outside the grouping symbol, like this, well, that indicates a vertical shift or, either going up or down. Now that's +3, so it's going to go up. But when I say what we're going to do for horizontal shifts is we're going to look for the shift within the grouping symbol itself. So let's say we have the absolute value of just not x, something like that, but we have like x minus 4, something like that. So if that is true, this means it's got a horizontal shift of right 3. So it's going to go right 3 units. Now that's not a mistake there. You did not hear me misspeak. I know it says -4, but the way horizontal shifts work is it's always going to be kind of backwards as to what you might think intuitively that you think it's going to be. And -4, I know it sounds like it's left 4, but it really is right 4. So what we're going to do is let's go ahead and just start. Let's not even draw the parent function here. Let's start with just the shift. Now this one, like I said, this one's indicating that it's a horizontal shift of right. I put right 3. I meant to put right 4. Where did I put right 3? I'm not sure. But this has got a horizontal shift of right 4. That right here is where the vertex of that graph is going to be. And then some other points. Now we know that the general shape of a absolute value graph is a V. There's not much room on the right, so I can at least draw some points on the left. Let's see if that holds up. Let's just pick a random point there and see if that works. Let's pick that point right there, which is the coordinates of that point are 1, 3. So if I put that in as an input-output, does that come out? If I put in a 1 for x, does that give an output of 3? Does it do that? And of course it does. 1 minus 4 is -3, and the absolute value of 3 is 3. So that all checks off perfectly right there. So that is your horizontal shift. Okay, so what I did for the next one here is I wrote out a quadratic function. I wrote out a quadratic function, right? Got x plus 3, and it's within a grouping symbol, parentheses, and it's squared. So what is this telling us? Now this has got a plus 3 right here. And like I said, when it comes to horizontal shifts, everything is kind of bizarro backwards. And so this is going to have a horizontal shift. It seems like it's right 3, but that's going to be left 3. All right, so that was left 3 units. 1, 2, 3. So I went left 3 units, and that's what it is. So let's not even start with the parent function. Let's just go ahead and just draw it. So we know that that's going to be right here. We know the vertex of it is going to be right there. And then, the general shape of a parabola is we know that there's a point here and there's a point here. And then when we go 2 over, 2 squared is 4. So I'm going to go right 2 up 4. And the thing is, whenever I show people these shifts, is that if you don't trust what you just did, this is not the easiest thing to do kind of off the top of your head. If you don't trust what you just did, test out a point and put it into the original function and see if it all holds up, So let's say I put in right there, that point is -1, 4. So let's say I put in -1, 4 into that function. -1 plus 3 squared, does that equal an output of 4? And it should, because -1 plus 3 is 2. And 2 squared is 4. So that works perfectly. Okay, so let's say we have a square root function. Now, square root function, that's the parent function right there. And for a square root, the grouping symbol in this case is the actual radical. So the radical is going to be extended a little bit, and it's going to change depending on what's either being added or subtracted to it. So for this one right here, this is indicating a horizontal shift of what? So that indicates a horizontal shift of left 1 unit. So the parent function looks like this, of a square root function, looks like that. So that means it's going to have a shift of 1 unit to the left. And again, if you don't trust that answer, let's go ahead and just test out some points here. And that point right there, if I pick one out of the choices there, if I pick that one is, that's 3, 2. And if I put in an input of 3, does that give an output of 2? Well, 3 plus 1 is 4. And the square root of 4 is 2. So that holds up. Everything works really well on that one. Okay, so that's how horizontal shifts work. And remember what I said, when it comes to horizontal shifts, we're really going to focus on what's added to or subtracted from the x. And it's got to be within, it's got to be inside the grouping symbol, whether it's inside the absolute value, like right here, or inside the parentheses with a quadratic, or inside the radical when it comes to square root. All right, moving on to reflection about the x-axis. What we're going to do is we're going to look at what will make the graph of a function reflect as if this was a line of reflection over the x-axis. And what that just means is, let's say I just draw kind of a random shape here. Well, that would be reflected over the x-axis, kind of like it would look something like that, So reflection, if something was over there, the reflection would be over here, of course. Okay, now as usual, let's start with the parent function of an absolute value graph. An absolute value, if you haven't figured it out already, is a v. Okay, so what will make that reflect? Now the thing that will make it reflect is if you add a negative sign or a negative coefficient in front of it, not within the grouping symbol though. So the reflection is going to look like that. So they're going to share that point. All right, so that right there, that's the function of the absolute value of negative x. And right here, this is the function of just the absolute value of x. So notice that when there's a negative value in front of the parent function, that is going to flip it. It's going to invert it, and it's going to flip it over the x-axis itself. Now let me just go ahead and just do a quadratic function. Now, if it's a quadratic function, obviously the quadratic function, the parent function of it's going to look like this. That's the parent function right there of a quadratic function. And if you want to make it reflect over the x-axis, all you have to do is just kind of put a negative coefficient in front of it. So negative x squared. Sorry, I'm in my basement right now. If you hear water dripping, the sub pump just went off. It's not somebody going to the bathroom or something. So that's it. So you get the general idea of how this goes. It's it's going to flip it over that x-axis. That's going to be a reflection. And those are the things. I know I'm throwing a lot of new things towards you. You know, there's a vertical shift, there's a horizontal shift, there's a lot of, kind of a combination of everything. For this next part here, we have to graph f of x and the g of x functions on the same axes and identify the domain and range. Okay, so the f function right here is basically the parent function of a quadratic. It says identify the domain and range. All right, now the domain of the f function is going to be what? Well, it's all reals. It's every x value is a possible number on there. So like this x value right here corresponds to that number or that value on the function. This x value right here corresponds to that. There's an x right here, and it corresponds to that on the y. See, it has a corresponding y value. So everything on I know we're limited with our just kind of what we see on paper, but everything on the x-axis is covered. All right, the range now notice for the range we're talking about y values. So what y values can work? Well, it's going to be f of x is greater than or equal to 0. So all those values right there should work. 0 is a value on the y, the f of x. 1 has a spot right there. 2 has a spot right there. If I venture into the negative territory, here's where negative 2 is. Well, there's no corresponding point at negative 2 on the f of x or on the y-axis. All right, now let's go ahead and graph the shift of it, or the transformation of the g of x function right there. We got x minus 2. Now notice the minus 2 is inside the grouping symbol there. It's inside the parentheses, which tells us it's going to be a horizontal shift. And I know it says minus 2. I know it says minus 2, but it seems like it should be left 2, but really we're going to go right 2. So that's what we're going to do. All right, now there's no vertical shift to this whatsoever, so I'm going to go right 2 units. So I'm going to put the vertex right there, and then I'm going to go ahead and there it is. Okay, and so the domain and the range for this one is going to be the same. So the domain is all reals. The vertical, the horizontal shift of this did not change the domain, nor did it change the range in any way. Okay, now moving on to number 2 right here. We've got the f function, which is a square root function. It's the parent function of a square root. And the g function is a little bit of a transformation. Now, what transformation is indicated here? Now remember, the parent function is just what it is. The parent function is going to be like this. 0, 0, square root of 1 is 1, square root of 4 is 2. So there's your parent function right there. And let's go ahead, while we're at it, let's go ahead and just write down what the domain is and what the range is. Now the domain, here, if we look at what, the domain are all the possible x values. So let's look at 0 is 0 is a value on that right there. 1 has a corresponding y value right there. 2 has a value right there because it corresponds to the y right there. 3 right there, etc., etc. So it follows that pattern right there. Now, remember, when you find domain, when you're talking about domain and range, you're always going to think about what are the constraints. What can it not be? And right here, this whole section right here on the x-axis is omitted. There's no values on that graph whatsoever that are represented in that function. So the domain for this one is going to be x is greater than or equal to 0. All right, as long as x is equal to 0 or greater than it, then it's part of the domain, because none of these numbers right here are possible values for the domain. Remember, the domain is, if you're wondering, domain is x. All right, now the range value, let's think about what the range is going to be. Well, the range is the f of x, which is just the y, right? But the y has to be greater than or equal to 0. So notice, like on the last one, there are no y values that go into this territory, into the negative territory. So the y has to be equal to or greater than 0. That's it. So I'm kind of glad I did these separately, because it might get confusing once I have both of these down. Now let's get to the transformation function right here. Now the transformation function, what does that tell you? Does that tell you, is it a vertical shift? Is it going to move it up? Is it horizontal? Is it going to move it left or right? Or is it a flip? Is it a reflection? What we've learned is that when there's a minus sign in front of the function itself, it is a reflection. So it's not vertical, it's not horizontal, it's a flip. So this should be reflected along the x-axis. So that point doesn't reflect, but there's reflection of 1, 1. And then the reflection of 2, 4 is going to be 4, negative 2, I should say. So there that is. Let's talk about the domain of the flip of the reflection of that function. Now the reflection of that function, that does not change the domain in any way. So the domain is still going to be x has got to be greater than or equal to 0. The range, however, does change. Now notice, the range now, we can cover these negative values. This negative 1 is a value on that function. Negative 2 is a value on that function. I know you can't see it, but negative 3, somewhere down the line, that's a value on that function. It keeps going. So the range this time around is going to be that f of x is less than or equal to 0. So all those values that are less than or equal to 0 are possible values in the range. Moving on to number 3, what kind of graphs do we have here? We have absolute value. So the absolute value graph, I know you're probably getting sick of doing this, but I mean that's a good sign when you're doing math and you're like, okay, I get it. That means you learned it. That means you understand it. That's a good sign. So that's what the parent function of an absolute value looks like, just like that. And let's go ahead and talk about the domain of that. Now the domain for that particular function is going to be all reals, because there's no x value that is not a part of that function. This x value right here corresponds to it. This x value corresponds to it right there. This x, everything corresponds to it. The range, that is not so much going to be all reals. Now the range is going to be f of x is got to be what? Now notice the range is only in the positive territory. So the range has got to be greater than or equal to 0. Now let's look at the g of x function. Now the g of x function has this plus 4. All right, so what kind of transformation or what kind of shift is that telling us? Now the plus 4 is outside of the grouping symbol. It's outside of the absolute value. So it can't be horizontal. So this is telling us it's a vertical shift. So it's going to be a vertical shift of up 4 units. That's what it's going to be. So it's going to be up 4 units. So when we graph this, we're going to go up 1, 2, 3, 4. And that's where that is. And we only have so much room here where we can draw it. And I should be labeling these. This is the g of x function. This is the f of x function. Now let's look at the domain and the range. Now the domain, does the domain change at all for the g of x function? No, it's still all reals. Now the range, this makes sense. Now this is a vertical change. Now remember, range is the y values. You know, that's what range represents. I mean, we're not calling it y, we're really calling it f of x. But you know what I mean. It's all the same. So the range, or this particular equation is indicating that this is a vertical shift. So that is going to change the range. That's going to definitely be a change in the range. So the range this time is going to be all values of y, or f of x, that are greater than or equal to 4. So that is it. So as long as 4 is a value on that, 4.5, 4 3/4, 5, but anything below 4, anything less than 4 is not going to work. Going on to number 4 here. Now this has a little bit of everything. For number 4, we have absolute value sign. Now an absolute value sign means that it's going to be one of these functions. It's going to be a v, right? So let's kind of dissect this and kind of pick this apart and just make sure we know what everything means here. Now let's start with the plus 1. And what does that tell us? Now the plus 1 is outside of the grouping. It's outside of the absolute value. So that represents a vertical shift. So what does that tell us? We're going to go up 1. So we're going to go up 1 right there. And then we have the minus 3 right here, which is within the grouping symbol. It's inside the absolute value. And that tells us it's a horizontal shift. Now remember, horizontal shifts are tricky because they don't seem they're not really like what they seem. They are kind of bizarro backwards. So that's going to be a horizontal shift. Now I know it says minus 3, but this really means we're going to go right 3. That's what we're going to do. So the vertical shift is we're going to go up 1, and it doesn't matter what order you do this in. So we're going to go up 1, right there, up 1, and then we're going to go right 3. So 1, 2, 3. So there's where I'm going to begin that function. And then knowing that this is a absolute value, well, we just know it's going to be like this. It's be one of those V's. Now the domain for this one is going to be all reals. There's all values of x are fair game for this one. And the range, well, this had a shift. It went up 1. So the range is going to be all values of y, f of x, that are greater than or equal to 1. Okay, so that's where I'm going to stop for section 12.2. I am not going to do piecewise functions. I think if you take, if you keep going through algebra, take like a college algebra or intermediate algebra, you're going to get to that anyway. And they're going to reteach it because nobody remembers piecewise functions. But yeah, we're going to skip that, and that's kind of confusing anyway. So I think this is a good place to stop. All right, so that's it. So we talked about shifts. We talked about transformations and how things change. And hopefully from this lesson, you got a good idea of what the parent functions look like of an absolute value, of a quadratic, and a square root function, and even just like a linear function, really. And just kind of how things move around. So knowing how they move around and what numbers tell you, you know, what they tell you, whether it's horizontal or vertical, or whether you're going vertically positive or vertically negative, or horizontally negative or positive. We know what to do now. So that is it. So everyone, I hope you got this lesson and this makes sense. And of course it makes sense, right? Of course, you guys all totally get this. This is easy. No, it's not. This is not the easiest stuff, but I'm sure you guys, you can always stop the video, rewatch it, go back, ask me questions, do whatever you need to do. All right, so everyone have a great day. Hopefully you're staying safe out there. Take care.